I should be on. Oh, there we go. It wouldn't be weird if I didn't have a slight technical difficulty. All right, I think I'm good. Maybe I'll boost the audio a little bit. I will say, even though it's been a challenge, it's day 26 and I'm excited. I don't know, I've been feeling pretty good. So today I'm just gonna do like a good hour, just for the one time. I didn't really think, well, I know what I kind of want to do today, but I didn't really check ahead of time to see if everything was there that I needed. So I'm gonna start with that because it don't feel like it, but it was yesterday. The weights and biases talk was not that long. It was only actually an hour. And then there was a repo that I can pretty much go through and kind of digest some of the information from. And then I haven't used the weights and biases platform, and I think that's I had missed the first 10 minutes of it. So I'm thinking maybe, I can actually get a general sense of how I could set the training up in weights and biases, and then I can play around with it. But I did clone the repo yesterday, I think. Did I? I thought I cloned it. Oh wait, what's happening? What? That ain't right. . I should be legit now. Yeah, I'm legit now. Okay. My battery pack was dead actually, but it's all good. But yeah, how did I miss that, man? I missed my logs for yesterday. So I got a gap in my graph, but it's all good. I can't be mad. It was I did 2 streams back to back. That was real chaotic. I don't know if it came across like that when y'all was watching, but it was real chaotic because I was doing the I want to say I was doing the podcast, and I did a podcast and my regular live streams in 2 different softwares. So I had to, first of all, the software I do the podcast in wasn't even working right. So I end up accidentally leaving the starting music playing like for like the first, I don't know, 5 to 10 minutes of me talking through the podcast. The music was still playing. And then I finally thought about it like, wait, I don't think I turned the music off. So then I finally turned it off, and I went back and listened to it yesterday, and I was like, yeah, the music was playing that whole time. So, we just gonna have to roll with that. I don't think I'm gonna be able to edit that out unless one of those AI editing tools is able to take, I don't know if y'all know about an AI tool that could take the backing track off of my podcast. Let me know. Otherwise it's just that's how it's gonna be when it get published. So I had that one, and that was already chaotic, which is why I was late getting started, because my audio levels and stuff wasn't showing in the software, so I couldn't see the audio levels of the music, or I couldn't see my audio level. I couldn't hear myself. My monitoring wasn't working for some reason, so it was just a hot mess. And then I ended up being late for the nanoGPT talk, but that's crazy because I could have sworn, I guess I didn't go through with it. I must not have went through with it. Damn. That's okay though. I was supposed to clone that repo yesterday. So let's just check in and see what time is it. It's 11:50. So I do want to try to get my log in first. So I think it was oh, here we go. Okay, so here's the rewatch. So here, I'm gonna put this in the chat real quick in case if anybody do want to go and see it, you can still see the rewatch. But I will say be careful if you wait too long to watch the recordings, because if they put another event up on this same URL, then from what I've seen in the past, those recordings are not going to be there anymore once this page changes. So if you want to go back and watch this recording, you should do that ASAP. I am going to put it on a rewatch like I did yesterday, but I'm kind of torn. Maybe I'll split screen it with my code so that I can, because I do want to be able to show it, for reference, so y'all can see it. But for me, I still want to be able to work on the project alongside it. So I think I can get away with a little split screen like this. So that's there. And then they were supposed to, it was a couple resource links. So rewatch. I gotta do all this wait, can I just, hold on. Let me see if I could just do my Gmail, because I already registered for this. I did see that they sent a follow-up email about it too. But I thought it was a good event overall. So it was so much going on. I didn't really get to stop and kind of set up everything so I could follow along. So I thought that the way he was explaining it and breaking everything down was kind of helpful. So I'm going to, I'm just going to pull up my email and see, where's the follow-up email they sent? Oh, here it is. Rewatch. Okay, and then they sent us the links. Okay, so here's the repo. Hello, open. Okay. Got that. And then we need, I shared the other links, but they had the prompts. Man V. And then they had the LLM course. They have this coming up. Copy link address, I guess. These are two of the links that they had for, you know, just more resources and everything. So if you want to follow up with those, then you can. And I think I put them. Did I put those on Notion? I either put those on Notion or I put them in Discord. I can't even remember now. But yeah, one is wmb.courses/training fine-tuning LLMs. I'm pretty sure I put this one on the Notion board, so that's already there. And then the site prompts page. I might jump into this and see. I think this is, let me see. Intuitive visualizations allow you to integrate every step of your LLM program. Easily review past results, identify and debug errors. Okay, so this might have been what he might have showed something about this yesterday. So I'll come back to this. And if I need to, I'll put the links again, but I'll put them in chat at least. And then I'm going to do my log real quick, and then I'm just going to run this video back from the top, and because I just thought the explanation and everything was really good. He was breaking everything down, so at the very least I want to understand the baseline of this repository before and see if there's anything about getting set up with weights and biases. So where we at? GitHub repo. Okay, rewatch. And then I don't know if they do have a server. Weights and Biases has a Discord server. I've been in their Discord server since we watched that one conference, the last Fully Connected conference. I think it was in February. So I've been in their server since then. And in our server, we have I have a channel that is like AI ML community announcements. So it follows like the announcement channels from some of the other AI channels or AI servers that I'm in. So I did update the server because for some reason I wasn't following the Weights and Biases announcements. They have some of the best community announcements, I think, because in addition to talking about stuff that's platform specific for them, they also do announcements around, sometimes you will see them talking about other models, you know, just different community things. And they also do a lot of different events or post about different events and stuff that's going on. So I do recommend that. I will put the link. We have Discord, so if you look in the Discord and you look for the AI ML announcements channel, that's not a channel that we post in. That channel is following multiple AI servers. Their announcements. All right, so we're here, and okay, so let me go back to Visual Studio Code, and let me go see. Let's do. That's crazy. I didn't even do 25, man. I'm mad at myself, but it's okay. Let's do them one step at a time then. So for 25, which was June 1, let's see. That's so weird. Because I remember, I'm tripping. I remember putting all that in there. I remember putting the title in here and everything. It's okay though. I was moving so fast. I probably didn't. Did that work? No, I'm pasting in the wrong spot. Man V. All right, so yesterday I was doing, oh, I guess I wasn't doing this yesterday. So undo. Probably I was still doing that, right? But on 25, with this here. So okay, so that catches me up somewhat. Now today, not even gonna lie, I was just trying to really get that commit off before midnight. So I hope that counted, man. I don't know. It's something about my graph being all green that's like encouraging me to continue my streak. So you gotta hack your own brain, honestly. And I am pretty decent at hacking my own brain. So I kind of know the things that are motivators for me, and I try to take advantage of that or optimize on that, I guess you could say. I'm trying to adjust it without me. I don't want my audio to be too loud. All right. Show. I don't know what it is, man. It's hot today. All right, so this one has both. So I was reading on, what was that, Wednesday? Thursday. This is Wednesday. This is Thursday. Okay. So yeah, Wednesday I was still reading. I think, let's see. Oh, I'll just say I continue reading. I thought I was actually tracking which topics I was covering, but that's okay. But I do remember when one of the things we were talking about I think it moved into different bias in AI in the Fast AI book. So that's what we were talking about then. Then obviously yesterday I was watching the presentation from Weights and Biases. So I'm just going to pick myself up by my bootstraps and keep moving forward. Did I change anything for? Yeah, I guess I did. Okay. One of the things I was going to say too, I feel like it would actually be helpful after I do this process to go back and watch the state of GPT. So some of the things that I think maybe went over my head I might be able to digest it a little more now that I have a practical example of going through a GPT training process, or at least seeing how it all is set up. So that's kind of how I'm thinking about it too. So we're going to move forward with this. I'm going to. I'm actually gonna get rid of VS Code. Oh dang, that was not smart actually. I might end up wanting to clone that, so we'll just leave it open. And I can get rid of this other window for the sake of my computer. So I wanted, oh, I think I remember I got stuck. I was like, do I just want the master branch? And then I never ended up cloning it or forking it. It's okay though, it's all good. I want to keep all the branches though. He had some working branches on this repository and they seem decent enough that maybe I would want to see them. So yeah, Siri, I'm literally not talking to you. She told me she paused the music for me. Nobody actually do that. How come when I want Siri to do something, she don't know how to do it, but then when I don't want her to do nothing, she just be hopping in like nobody asked you. That's all. It's okay. She's trying. All right, so we should be good now. I'm gonna refresh. I don't know why I keep tabbing my graph like that. Okay, so where are we now? Let's come here and I'm going to, oh, she probably heard me saying that I wanted to pause the music, but I wasn't telling her to do that. I'm gonna move this one over to here. Where did it go? Oh, here it is. Okay. Hello.
Follow him in
Oh, there
Twitter.
we go.
Training GPT from
Sorry, I don't
scratch
got
with Nano.
patience. They taking a little bit. Yeah, so it's a solid hour on the actual recording.
All right, welcome. I see we have a pretty full house. Let's take a look at what we have planned for today. So thanks everyone for joining. My name is Andrea. I'm your host today. And today is all about training GPT from scratch with nanoGPT. It's all over the place. It's absolutely viral. So what we're going to do today is we will do like a hands-on live workshop. So this is a live event and you will understand the mechanics behind GPT and literally gain a deeper insight into how it can be used and modified for specific text generation needs. And after the next 60 minutes, the goal is for you to really have a clear understanding of GPT, to get a knowledge of how to run nanoGPT for its purposes. And then also you will be able to track auto training using weights and biases. And all of that is going to be run and presented to you by Thomas, who I'm going to bring on stage right now. Thomas is our machine learning engineer at Weights and Biases. He puts out a lot of content. He has plenty of years of experience, and he is going to walk you through today's webinar. So thanks so much, Thomas. We're excited to have you started.
Hello, everyone. Thank you, Andrea, for the introduction.
Well, I was about to say hi to him.
The
like
stakes are high, so I will try to deliver. I'm gonna share my screen, and we're gonna go through some slides, and then like go and move to do some coding. So yeah, let's bring that screen. And yes. I have a small slideshow just to put some context into this. Yes, I'm Thomas. I'm a machine learning engineer at the growth team. I play with the tools that come out every single week. I try to keep up as everyone else, and nanoGPT was one of those tools. Of course, we are really fans of Karpathy. He's a great professor, a great researcher, and he's delivering a lot of content for free for everyone. So I encourage you to follow him in Twitter. He published a lot of valuable content in general, and he has a really good YouTube channel with, I will link I will link on the slides. So let's get started. Basically, the original repo that Kapati put some years ago was mini-GPT. Min-GPT is like a minimal implementation of GPT, this big OpenAI model um, that we'll discuss a little bit later. But yeah, everyone uses ChatGPT right now. ChatGPT is kind of the same architecture that powers the original GPT paper. And yeah, we have seen there's multiple implementations out there in GitHub by the open source folks at Hugging Face. And most of them are like production ready code. So very big code bases in general. But basically, MinGPT is it's an abstraction and a minimal version of this GPT architecture and trying to do it as minimal as possible, ideally everything in a single file. But yeah, this was a couple years ago. A lot of people contributed, a lot of PRs, and the repo started to grow, and still a super nice repo to take a look. And the initial idea to make a super simple like this boat riding instead of like the full destroyer boat, um, yeah, kind of got lost. So Kapati, a couple years later, like early this year, he created another version called nanoGPT. Basically, he took the same image and was like, okay, yeah, MinGPT used to be that. Now I'm going to make something even smaller, simpler. And as you can see, we will see it, train.py, it's basically all you need to understand. And the GPT model is the same as before. But yeah, 300 lines of Python and you are ready to train a state of the art and reproduce basically the GPT-2 paper results. And as you can see, and this is like from the README of the repo, in the front page, we have a weights and biases training loss. So this is the validation loss, and you have a graphic, a plot that comes directly from a weights and biases dashboard. And yeah, this encouraged me. When I saw this, I was like, okay, I need to try this. This basically, yeah, it's doing some cool stuff and using weights and biases, and I need to try that. So yeah, actually, how I ended up here, Kapati put a set of videos like from zero to hero. It's called. It's a set of videos that takes you through this journey of like creating LLMs from scratch. And yeah, he
Oh,
goes
I
by
have seen
explaining
his stuff on YouTube.
backpropagation, and then he builds these
He has a good
videos
channel. I
that
think I am
start
following
building
him.
on top of like simple LLMs and then increasing complexity, multi-self attention, understanding what exactly is multi-self attention. And I'm not gonna explain that to you. He does it way better than me. It's a 2-hour video, and Karpati's voice is still really fast. So for me, it's like a 3-hour video actually. Um, and I encourage you to take a look at that, because basically everything I will cover today, it's pretty well documented on that video. So yeah, with that said, that's the GitHub repo for nanoGPT, Karpati/nanoGPT. And exactly what is GPT? I'm not going to explain you all the details, but this is the gist of what GPT is. Yeah, but first we need to talk about this guy, the transformer architecture, not Optimus Prime, but that guy that comes from the attention is all unit paper. Actually, this slides I'm going to present you now come from another talk from a friend of mine, Lucas Bayer. He works at Google, and he put together all these slides about attention is all you need, basically, and explaining how attention is everywhere now. So yeah, we have multiple types of this like encoder decoder models, and GPT is like the decoder only model basically. But is the encoder only model, and T5, sorry, oops, I skip a bunch of slides there. T5 is this model that encompasses like the multi-head attention, basically complete with the cross attention layers
Did he
between the
give us the
encoding
link to
part
the
and decoding part.
slides?
So for us, as you can see from this
Because
slide,
this is
decoder only
real
GPTs
struggling.
is
Hey,
basically a
preacher.
bunch of
Um,
multi-head attention layers.
Today I'm actually running this back from yesterday since I was in a frenzy trying to keep up with what was going on. I did just clone the repo, so I'm actually going to try to follow along with the explanations and stuff. And I have missed this whole first like 10-15 minutes of the presentation, so yeah, it's all good. I don't know. I'm feeling pretty good because what's one thing that's different about this time that I'm doing 100 days of code from the last time I tried. And again, I almost got to the end of my 100 days with my live streams, but it's like it feels more sustainable now. So like earlier, I got some rest in. So since I got some rest, I feel I feel so much better when it comes to like starting the stream, even though I started late. But yeah, how are you today?
Transformer layers on top of each other. Actually, I think, yeah, GPT-2 had like 32 of them. So yeah, it's a pretty simple model. And it's, as you can see here, it starts from the bottom to the top. So it starts with a sequence of tokens and predict the next token. So it's basically something you can train unsupervised. You just give
Doing
him like a
good.
lot
Sounds
of text
good.
and just like mask the past. So we use this thing called causal attention, that like you only let them all see the past tokens to predict the next one. So yeah, this is a models are scaled really well, and you just need a lot of text. Just to keep a glimpse on, there's multiple papers on transformers, but yeah, the initial one that gave the name Generative Pre-training Transformer, GPT, it's the Improving Language Understanding by Generative Pre-training Transformers. This is from OpenAI. It's kind of a date paper now, but it has a lot of cool ideas that still applies. Like they basically took this no new architecture, simple transformer architecture that can scale really well. And they pre-train this on a super large text corpus, and then they just fine-tune on the specific task, and they beat every single tailored specific model by a large margin. So this showcases the power of GPT actually. And then years later, we have the actual GPT-2 paper came out. Um, and yeah, they the most interesting thing that they put together this web text data set that is not public, but it's a super
Oh,
big data
preacher, I
set,
was reading that
a lot of tokens in
paper,
there. I
no,
think
that
like
post that you
3 billion
sent
tokens.
in
So this
Discord
thing,
too about
yeah, they scale
the
up
case in
GPT-2
In
XL. It's
Japan.
like 1.6 billion parameters, and
So I gotta
it
look more
actually,
into
yeah,
that.
beat all the
I think
zero shot
it
learners
seemed
by
like they
in
said
7 of 8 tasks. It's better than specific.
basically any data was fair game, even copyrighted data, even data from like illegal websites. Which and I just briefly skimmed it, but it seemed like that's what they were saying. I'm like, yeah, that's kind of my mindset because it's not. I don't know. Only because I feel like if that's the case, in my mind, it's like you shouldn't be going after the AI training companies because of what's on the open web. You should be going after the actual companies. Like you need to assert your copyright at the source, not because then it shouldn't be there in the first place. You can't just put it on them just because they're using it. But I don't know. I don't know. Tell me if I'm wrong, but from what I got from that. But that's what I was getting from it, just from like a quick. Um, I clicked on one of the links and I was reading into it. So I'm gonna look into that later, sometime this weekend.
Specific malls. And yeah, and as a quote from the second paper, like this finding suggests a promising path towards building language processing system which learn to perform tasks from the naturally occurring demonstrations. And if we put that in 2023, we think about the prompts engineering, and then we are using this model as zero-shot learners. Basically, we are just giving them a lot of content in the prompt, and then they are capable of producing incredible outputs. So what is weights and biases doing here? Okay, weights and biases, most of you suppose know, it's an experiment tracking tool. And yeah, it's the system of record to keep track of all your machine learning pipelines, journey, and experimentations. And you can say like you have a specific tool for different, um, yeah, different tasks. And yeah, for machine learning, we are like the tool equivalent um, for your daily machine learning tasks. Weights and biases is a Python library. It has a public open source client. You can go at
Oh, I
1db
didn't
slash
know that
1db.
part.
It integrates with a lot of frameworks, with PyTorch, with more than 6,000 integrations all over GitHub, with all the standard frameworks. And it gives you this nice UI to visualize and keep track of everything you're doing on machine learning. So to get started, it's basically pip install 1db.
Okay.
That's what you will need to do
This is
actually to
what
run
this is what we're gonna need to
nanoGPT.
follow
And
up
then you will
on.
need to call init. Init is the way we we create a run. A run is like an execution of your experiment. So that will tell with somebody says, okay, keep track of everything that you call inside your training loop, like 1DB log, your metrics, accuracy, validation, loss,
Ah,
images, the model checkpoint, and then have all this like reproducibility for free by using weights and biases.
okay, hold
And what
on.
why we're
Pause what you saying right now. Okay, so let's see. I'm trying to think. Okay, I gotta go to my desktop first of all. I think I have an AI ML space, but think I have a I think I have a what you call it a dang, I got separate. I was gonna say I think I have a virtual environment, but I'm pretty sure it's like specific. I should have set it on this whole space. Um, yeah. Okay, that's fine. That's fine. Um, I've been trying to be a little bit, careful about my I'm just gonna put this one up here. I've been trying to be a little bit careful about my environments, but let's hope I don't regret this. I might. It's okay. Oh, I got to do PIP 3 because I'm on Mac. WAMB, and then that's doing stuffs. I've been wanting to use weights and biases, so I'm excited. I just wanted to get this all set up and kind of like get that rundown. I'm not sure I want to do. Oh, I guess maybe it might be time for me to do the PIP update. I don't usually upgrade immediately because y'all know them first runs of like, especially like a major update like that be breaking stuff. But um, it's at 1.2. I might update that soon, but not today. Okay, so once I did that, I should be able to. He'll probably show us this again, but I'm gonna do this.
we're doing this because nanoGPT uses weights and biases.
Dang it.
So this is the ability for free by using weights and biases. And why we're doing this because nanoGPT uses weights and biases.
I'm
So
slow. I'm too slow
this
for the.
that you call
Oh
inside your
no.
training
Oh, I,
loop,
I
like
did the full
1DB log, your
screenshot. That
metrics,
wasn't good.
accuracy, validation,
Oh,
loss, images, the model checkpoint, and then
okay.
have all this like reproducibility for free by using weights and biases. And why we're doing this because nanoGPT uses weights and biases. So this is nanoGPT is constructing a model from scratch or fine tuning. So it's basically putting together an LLM from scratch. So
I
you
need to
take a data
explore
set, you take this big
every company
architecture,
on
you
here.
train for a couple of hundreds of
Cohere has
hours,
one
and
of
you
the
get this
classes on
like
the AI
powerful model.
list.
And most of like LLM creators, actually from the Attention is All You Need paper, 6 out of 8 authors use weights and biases. And as you can see, these are some of the companies and open source labs that use weights and biases on their daily driver tool for machine learning experimentation. And of course, Kapadi likes weights and biases, so that's why we're here. So let's go. Let's not do more introductions and let's try and take a look at nanoGPT. So I'm gonna make this bigger so you can see. This is the
I'm
repo.
going to
It's a pretty simple repo.
try and have my repo up as he's going through because yeah, I don't know what was up with it. It could have been the software they was using because his camera was clear, but his screen, the resolution was real off. So yeah, let's see.
Repo. It has a pretty detailed README. I like when you have that. So you haven't come here, like I encourage you to take a look here. We will do that. It has a lot of pull requests. I think Carpati has a lot of work under his nose, so pull requests tend to be slow to merge, and some issues are mostly people asking random questions about LLMs in general more than actually asking questions about nanoGPT. So yeah, this validation loss is what you would get if you try to train GPT-2 XL. No, this is GPT-2 small for 4 days on a 8 times A100. And you will need this to actually run nanoGPT. So basically PyTorch. I encourage you to try PyTorch 2.0 if you haven't, because it's faster and this repo supports it. It's just a bunch of transformer layers that compiles pretty well.
I'm trying to
It
think if
requires
I have.
NumPy. NumPy will be used. I will explain you
Do I
why.
have
It
PyTorch? I
requires a
should have
transformer
PyTorch.
library. This is basically to load model checkpoints so we can grab OpenAI's GPT-2 pre-trained models. The dataset library, this is actually to download the datasets. TikToken. TikToken is OpenAI's specific tokenizer. It's really fast. It's written in Rust. You need that because the model use that tokenizer. Like you cannot separate models and tokenizers go together. Because tokenizer is the way the model understands words. So, and you need 1DB. It's optional, but I encourage you to install it. And if you don't install 1DB, you will not have experiment tracking. And TQDM, also like to see the progress of your training. So you have multiple options to run this. Basically, I ran a bunch of these scripts already, so you don't have to wait for them. So yeah, he gives you this Shakespeare data set. This is like a subset of all Shakespeare, and you can quickly train them all from scratch using the Shakespeare data set, using this prepare script. Like if we go to Shakespeare.prepare, um, where's that? I think it's in
Thomas,
data here.
jumping in here real quick. Can
Hmm?
you zoom in a little bit?
Yeah.
Perfect. Thank you.
Okay. So yeah, Shakespeare charts basically all this data have these folders and you have a prepared.py script. I will not go into details, but basically every prepared script does the same, downloads the file and then like converts this to a specific file format that will be fast to read from memory. And as you can see, it actually converts them onto NumPy arrays. So once you have that, it dumps that into a NumPy array and a train.bin file. This is just a binary arbitrary NumPy file on disk. And yeah, this is a small file, so you can basically load the full file at once. So yeah, this will download and pre-process the documents so they are readily usable by the data loader from the train.py file. So yeah, 1 million tokens, pretty small. So you can try that and you will get a model that is capable of generating Shakespeare char by char. So it writes something that looks like kind of Shakespeare, but it's not. And then yeah, that's the first example. I encourage you to try that one. So yeah, what I'm doing, I'm gonna go quickly to show you. I'm using Jarvis Lab. You can use whatever cloud vendor you have. You will probably need a big GPU, like some of those, at least 40 gigs of memory, so
Ooh,
you
okay.
can train fast. And I
Duh.
also recommend you to use any Ampere series GPU because um, the code expects to use brain floats. Brain floats like this new PyTorch format that it's super fast and it has more precision. Um, and yeah, it requires an Ampere GPU. So
Hello. There's actually two questions in the chat. Shota asks, can you train that model in languages other than English?
yeah, you can train on. That's a trick question because I think the tick tokenizer supports multiple languages because we have actually used that for Japanese recently at the office. Um, so yeah, the tokenizer will work better probably in English or Latin languages, but it works in most languages. So if it will default to splitting the words, uh, it will use more tokens, but it should work. Um, I suppose, yeah, you could take a look at the G token documentation and check if, but that's the model is agnostic to languages. Basically, it's the tokenizer that will convert the words to basic tokens. And then you may, yeah, you may need to, if you change the tokenizer, you need to change them all because the embeddings use the tokens, basically the language. the vocabulary of the tokenizer. So yeah, it should be possible. And as you know, like GPT chat, it supports any language basically. I don't know if any, but a lot of languages. You can translate to French, to English, to to Japanese. So yeah, it's using the same tokenizer.
Awesome. And then there's another question by Rashmi. How is TikToken tokenizer different than sentence piece?
Oh, I'm not sure. Like this is a good question. No, I don't know the answer just like that. I will probably Google that and and come up with an answer.
I appreciate him
Um,
saying that.
And by the way, Gianni commented on the first question that if you're trained by character, it is language independent. So
yeah,
thanks,
it's
thanks
true.
for adding that. All right,
Yeah,
keep the questions coming. I'll hand it over back
yeah.
to you,
I
John.
will make a break every 10 minutes to ask for questions actually, but yeah, we have a lot to cover and we have only 1 hour. So
Perfect.
yeah, so I encourage you to try Jarvis if you
I haven't
haven't. It's
used Jarvis,
because it's
so we
cheap
can
and
get
it's
that
really
set
easy to
up.
use. So
Because he says
take
we need
an
a big
Ampere-based
GPU.
CPU. Most of them are. You could even use that one. It's like $1
I'm
per
not going to get
hour.
that set
Mine
up
have been
tonight, but
running for
I
34
will
hours
be
now.
prepared to do that
And you can click
this
here.
weekend.
I'm just open that, and this will get you here. So it gets you a Visual Studio Code on the browser. This is not Visual Studio Code. This is basically Chrome running VS Code on Jarvis Lab on the browser. So it's great. So this is actual repo. So we can go. Let me close everything because. So yeah, this is the repo, and we can take a look. I wanna go through the files a little bit and discuss some yeah decisions, design decisions that were made, and like I'm gonna close the terminal here. So yeah, it's this big enough. I suppose I can make it bigger, but yeah. So basically, the train file is whatever where the magic happens, and it's pretty non-standard train file because Carpathy decided to put every single parameter on the global scope, and that's if you go to a like more um, standardized machine learning train.py file, you will find like probably a configuration manager like Hydra, or if you go to Google repos, it probably will be MLF collections, or even a simple name server, or even a dictionary. But here, every single parameter lives in this spot, like in the global scope. And this is like a design decision that you may agree or not, but it simplifies your life because you are not calling like config.batch size, config.dtype. You're just calling the parameters. And then he overrides whatever you gave him, but executing the configurator.py. This is also a very weird file. It's basically overriding the global scope. No, yeah, it's you can like it or not. It's super simple. It's super straightforward. So basically,
It
you will
says, I know
go and you
people
can
are not
override
going to love
parameters
this.
by
I just
passing
really dislike configuration
yeah
complexity. That's fair, though.
the arguments to like a command line interface.
I hate
So yeah, so
complexity
if you go to
in
train.py, you have all these parameters. So basically,
introductory
you are giving
topics
him
in
like
general.
where do you want to save them all checkpoint, evaluation, every how many steps you want to do evaluation, like when are you logging stuff to weights and biases, how many evaluation iterations you want to do. Yeah, if you want to use weights and biases or not, like, oh, this should be true by default, but it's not. Um, the name of the project you want to save to weights and biases. OWT stands for Open Web Text. The name of the run name, you can put another name if you want. Um,
Again, me, can we
hmm?
zoom in a bit more
Yeah, I can.
to see more?
I will not have more space on my screen, but
Yeah, but that's a lot better. Thank you.
yeah, okay. So yeah, the other parameters are like it's using AdamW, so learning rate, like total number of training iterations, and then some like system, like if you want to use DDP, this is for multiple GPUs. So all this code works on like a pod of 8 GPUs or even in multiple nodes. So this is really cool. This is a super scalable training code. Default is bfloat, as I was telling you, and default is using compile, so you will need PyTorch 2.0, and it makes like them all 30% faster. And then like configuration override and like setting up the DDP. This is kind of verbosy. Yeah, you need to set up like stuff to how to like deal with multiple GPUs. And then I really like this, but it's also very non-standard. Basically, in every PyTorch machine learning pipeline, you will see this like data set
Poor man's
creation,
data
and then like a
loader.
data loader, and then like a train data loader, validation data loader, and then you will sample from the train data loader, run evaluation on the validation data loader.
Yes, we learned about
But
data
here's
loaders.
not doing
Yay.
any of that, because basically when you read text, text is already something you can scroll. You only need to tokenize it, and that's it. And
Hmm.
this thing is already tokenized, so you don't need any of that. Let me just put that on. Okay, so what he's doing here, he's basically reading the data set and loading that on a numpy man map. Numpy man maps are memory arrays that are not read to RAM. So you can read stuff that don't fit in your RAM. So it will be you will be reading when you are indexing, as you are indexing on the array. So this is a pretty efficient and fast way of reloading arrays. So this is loading the full data set, but without, like, it's a lazy load. So then he will go and just like slice blocks of block size, basically like
So
chunks
he's
of
like
text tokenized, and
reading
just
the data as he goes
slicing them with a
along and
rolling
then just
window. And that's
taking
it. That's your
chunks
data loader,
as
basically.
he goes.
And then he will stack them, and then you will get a batch. So this, as he put it here, is like poor man's data loader, but it works. Like, you don't actually need an actual PyTorch data loader for this. Cool. Then okay, then more loading. Yeah, what type of init do you want? Create a config. So the only thing that doesn't live in this file is actually the model. The model itself lives in model.py here. Um, where's model.py? Here. Model.py. So I'm not gonna go through that. You can. It's just basically the same as in min GPTs. It's a standard GPT model. So defining self-attention, multi-head attention, stacking the transformer layers, and you have a config of how many of those you want, how big you want the latent space, etc. So then you will load the model. So you can start from a pre-trained model or resume from an ongoing run. Imagine your run crash, you can resume. So this code does everything, like resuming. It's pretty good. And yeah, you can also initialize from OpenAI. So it's just doing GPT from pre-train. And I don't know if I can go here in the UI. No, this UI does not support like
No,
picking
that's what I
inside,
was
but
saying,
basically
man.
that's like
Y'all probably seen me
getting the
do that a million
checkpoint.
times. I'm so used to Java, IntelliJ and stuff like that. Like, um, yeah, being able to click into the source of the of the methods, whatever the source code is, and see them. But I don't know if there's a plugin that does that in VS Code. Somebody please let me know because I miss that so much. I used to be able to like control click, I think, or something like that, and then whatever libraries I had loaded in, it would then open up, the source files. So then you can actually scroll that code in the editor just like you would scroll through, the code that's in your actual code base. And that was so helpful. It was even helpful for me working with when I worked at a company where we did a bunch of big micro, like not a bunch of big microservices, but we had a bunch of microservices across like multiple teams. Yeah, it was really helpful because a lot of times you gotta click into here. It's like, oh, okay, that's how that works. Oh, click into here, see, oh, okay, that's how that works. Because you probably, working with some services from another team, and it's like you never seen it before.
And like loading the model weights. So yeah, that's more stuff like grid scalar. You need that when you're doing mixed precision, and yeah, optimizer stuff. And then like basically he has like an estimate loss function that will, yeah, compute the evaluation loss on train and validation. And then like he actually doesn't use the scheduler. He uses like a manually computed cosine and wire map scheduler here. And then if you decide to use weights and biases, it will actually create a weights and biases run. As I showed you before, this is the only thing you need to actually tell weights and biases, hey, we are doing an experiment here.
Mm.
So 1DB project, run name, this is something I added. So
The
job
job
type,
type,
maybe it's a good
and
idea
then
to make
whatever's
this
in
as
the
train, because we
config,
also have like sampling from the
which
model. That's
gives
another
some
different
context
job type.
to
And
the
you pass the
training
config,
run.
all the stuff that lives on the global scope here. And then you start training. Basically, you while true, while the number of iterations is lower than the total number of iterations. This is a standard training loop. Basically, estimate losses, And yeah, if you are using weights and biases, you log the values. So we are logging the training loss, the validation loss, the learning rate. And this is like a floating computation. How good are we using the GPU basically? And yeah, other more small details here, micro steps. If you're doing grading accumulation, this is more for distributed. If we are using routing clipping. So as this comes from Carpati itself, this is probably a state of the art kind of training loop for GPT with all the tricks. He shared a lot of these tricks in Twitter about like scaling laws, and he actually put a long book here about scaling laws and also like good ideas on how to like yeah multiples of 8 so the GPU gets everything fast. He put on, I remember a tweet about this on the vocab that you should probably scale the vocab and adjust to the next multiple of 8, and this gives you like a pretty big performance boost. Um, and at the end, yeah, this is something I added. You could log the model checkpoint to weights and biases to keep the model next to the run data, but don't do that probably because the checkpoint weighs 20 gigabytes. So yeah, you get 100 gigabytes for free in weights and biases for your personal use case. So if you log 5 of those, you are out of storage. So maybe for the smaller GPT, I think the smaller GPTs are like 1 gigabytes, 150 million parameters, maybe for those. But for the XL version, probably don't do it. And yeah, and once you have like run this, you will have to configure it. So he built some of the configurations, and as I said before, he's not using any configuration tool. He's basically dumping the config on a Python file, and that has advantages and disadvantages. But for me, the greatest advantage is you see like train Shakespeare chart. This is the first example he gives. This is Python, so you can actually do some small computations on the configuration that you cannot do in Hydra with your JSON files or on ML config. You can do it, but it's like, yeah, it's not straightforward. Here, it's like you can do whatever you want, like computing string time, and put that into a parameter. I don't know if there's more questions. We're gonna run this. So this,
No questions at this point. The code for this has been shared in the chat, which is a link to.
yeah, it's basically get
And
if you Google like
yes,
nanoGPT, you will get to the repo straight away. It has
perfect.
like 12,000 stars on GitHub. So
And
is
as a
this
reminder, we're gonna make the recording available, plus the links.
21
So
stars? Okay.
yeah, so you can rewatch at your own pace if you want to retry it. But yeah, we're keep the questions coming. Back over to you, Thomas.
Yeah. So yeah, I'm packing a lot of content. Like this is it's not as a big repo, but has a lot of like stuff going on. Um, so there's a lot of engineering here, like details about like how to train a model and enable the script to do DTP or multi-GPU, multi-node training, and a lot of like techniques of gradient accumulation and computations. And actually, you should watch like Kapathi's lecture on this. So Shakespeare char is this model that produces a super simple GPT that's next chart to prediction. And this model trains fairly quickly. So as you can see here, I'm running something. I'm actually training the big model, but I'm gonna kill it because it's not it's going nowhere. I was just gonna like trying to make it work, but it's yeah, you need a big 8 GPU node. I only have one here. So yeah, he gives you the configurations for all the stuff you can run. So I have run these three train Shakespeare char. So this is training from scratch. So you start from random weights, and then like you take the Shakespeare data set, 1 million token, um, and then you train them all to predict the next character. So it's not actually using tick token. It's just like next character prediction, and you use a baby GPT model, like number of layers equals 6 head, small embeddings, some dropout, and yeah, you put up kind of a high learning rate, and you train this. So how do you do that? Basically, what you would do here, it's you will let's wait for weights and biases to finish here. Yeah, let me just see if the GPU is available now. Yeah, this should be good. Okay, a new terminal here. let me kill that one. So yeah, the idea here is that you can just run Python train and you can pass the config. So here we will need to pass this config. So how do you do that? You will pass config slash, in this case is train Shakespeare char. This will tell like the train.py file to override only the parameters that are here in the config. Everything else will be default. So yeah, 1db log is off. We can turn it on here, or you can override via terminal here using 1db log equals true. It's equivalent to doing that. So if you do that, this will run this mall. So it has 10.65 million parameters, pretty small mall, 65 bucket size, because basically you have like 26 lowercase, 26 uppercase, some symbols, and special tokens for like dot, comma, whatever. And yeah, this will train them all for 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 I don't know how many. Let me check here. Um, 5,000 iterations, and it will learning rate is that, and it will log eval every 200 iterations, and then every 250 iterations, and then like log um, not too often. So it's printing every 10, as you can see. So this will create a weights and biases run. Like as you can see, when you launch the code, it will weights and biases is very verbosy, kind of take over your terminal. So it's telling you like, hey, I'm currently logged as me, and I have created a run for you, and the run already lives in the browser. So you can click on that link to go to the project or to this specific run. So if we click that, we get redirected to the workspace, and in the workspace you start to see that the metrics are being piped. So this is really cool. You can see the validation loss going down, the learning rate it's still going down, like it's like a cosine, like ramp and cosine. So yeah, we can see the GPU power. Yeah, we don't have many points yet, but this will be populating. And yeah, we are keeping track of everything that's happening in this run. So I don't know where's our code here. If I do that, oh, okay, it's here. So let me put that back. So this will run for 5,000 iterations. It's pretty fast, actually. If this, I'm using an A100 here. You can maybe tweak some of the parameters here, like the batch size, or what batch size are we using here? 64. So yeah, you will try to. I'm using NVIDIA SMI here to check that we're using all the. As you can see, I'm using only 3 gigabytes of my 41 gigabytes of memory. So yeah, we can probably increase the batch size. But I suppose this example, it's runnable on a consumer grade GPU, like an integrated graphics on a laptop, or even like on an M1 equipped MacBook Pro. So yeah, this will give you a model that's pretty basic, but it's a good idea. Start doing that to check if everything's working. So yeah, this is training, and we can go back here and we can see that the training, the quick start here actually suggests to do exactly what we're doing here. And yeah, you have to prepare the data set. I already did that all for the other data set, and it basically tokenizes and saves them as like memory arrays, and you get this train bean, val bean. Actually, if you want to do the web data set, the open web text, it takes like, I don't know, a couple of like an hour to prepare the data set. So it's good to do that offline, maybe on a machine without a GPU, so you're not burning your credits. And yeah, this takes about like 3 minutes. I'm using an A100, so kind of the same. And what happened when you do that is it actually creates a folder for you. So let me go here. It creates a folder here, out Shakespeare char, and it's pretty minimalistic, but it gets you the mall checkpoint. That's everything you need to run the mall afterwards. So this is your train mall. So this finished. Let me just open. I should probably put that guy into another window here. So yeah, it finished training. Let me reload this window, and we get that yeah, the learning red scheduler finished doing it. Like we get the full cosine, beautiful shape, and yeah, validation loss went down. But as you can see here, these are only training metrics and validation. We don't have any text. Like we want to see how the model performs. So you can actually do that by executing the um, the sample.py file. So let's take a look at this file quickly. So sample.py, it's kind of the same style, global scope stuff here, um, same Boersman's configuration. So yeah, it can start from a file. So if you give them all a file, so you give them all you give a model file to this code, um, you can load them all weights and then sample from them all. And like the sample happens here, so you are calling model generate, passing and starting token, and then like sampling from them all for a number of tokens. So max new tokens. So the default max new tokens, I think, is like 500 tokens, and the starting word is like like a new line. So here you could inject something like a phrase of Shakespeare, and then like it should continue with that style. So you can kind of prompt them all. So if you think as ChatGPT is exactly this. ChatGPT, when you put stuff on the system role or the user prompt, the model only does the same as this one, like predicts the next token. And when you put the question, is basically you are injecting the beginning of the conversation, and he will generate the rest. Um, I'm not saying ChatGPT is as simple as this, but it's the same type of model, like next token prediction model, auto-regressive way. So yeah, we can use this file and we can actually pass that. Let me clear here. So we can use Python sample.py, and we should be able to pass the model. So out Shakespeare, I think that should be it. Oh no, I need to pass the model checkpoint. So that guy. What happened here? We're going to sample from the model. Let me put this bigger. It takes some time here. Come on. Oh, my bad.
Yeah, I remember him doing this part.
I need to pass the out there. It's
I think when you
explicit.
like,
Yeah, this is the poor man's
it'll look like
configuration.
Shakespeare, but it won't
needs
be.
like
It won't be really.
It needs like explicit keyword arguments.
Coherent.
So it's Python sample.
But I assume we can do a little bit more work to
out,
get it actually, fully
here,
functional.
You passed. Let me just check I'm not doing it wrong. Yeah, you passed. That's what I was expecting, to pass only the directory out Shakespeare char. So if we do that, it should work.
Did he open a new?
So it's loading them all.
Did he open a new terminal?
And it's sampling.
Is
so
the other one still?
Basically, you get.
Is it still training, and that's just a checkpoint?
Here. So it's asking them all to generate 500 tokens, starting from that token 5 times. I don't think this is num samples. I don't think this guy is a parameter here.
I have 5% on my battery, so we are almost done at this
10,
point.
Sorry, it's 10. So we get 10 generations here. As you can see, this is not bad, but it doesn't mean anything. Yeah, what I have added here, that when you sample from a model like this, and yeah, you track your experiments and you want to keep track, what I would really like, but this is because I work for weights and biases, but what I would really like here, it's having the metrics with the model predictions in the same place. So what I did is, something I encourage you to do is, I added something here. So I had the same parameter as before, 1db_log. And if I use 1db score log, what's going to happen here is that I'm going to create a new run. So this sampling, it's also an experiment, so it's also a run. And it will create a table. And in the table, I would put the model name, what model I'm sampling from, what the start of the sequence I'm using. In this case, is like nothing, basically an empty line, and the actual sample generated. So then I can play with this, generate more samples, and I can store them on the central place.
You can see the samples that's generated alongside
like this. And then if I train more, I can maybe sample more from them all. and see if it's something better or not. So you can do the same thing as before here. So and do that and call 1db underscore log here and put true here. And I'm going to just give you the gist here. It's as simple as creating a table. You put what columns you want to put in, the names of the columns, and then you add the data like row by row to the table. So I'm table ID data. So I'm putting it, that's the model name. That's where the checkpoint storing the model name, the start token, and the decoded tokens. So the same predictions I'm generating here are being uploaded to the same workspace where this model was trained. So let's wait to the end. Weights and biases is pretty friendly and gives me a link at the end, so I can click that link and get redirected to the workspace and see what happened here. So yeah, we get this link. Let me open that. And this new run, it's not training, but it's a sampling, and we get this nice table rendered on the UI. So yeah, start is empty because
That's a
it
good
is an
tip.
empty line. But I encourage you to put something more interesting here.
Yeah.
Like, I don't know, a phrase. So we are sampling from the model name char, and we get like the previews, like the strings here. We can open this and see them bigger. In plain text, you can actually render them as Markdown, but this is not Markdown, so it's basically plain text. So if we run this more, what's great is that weights and biases know like, oh, you're logging the same table again, so it will like concat them. So you will have like all the model predictions. If you rerun this multiple times, you will have them centralized at the project level. So yeah, here we are. So I have already run a bunch of these experiments, so you don't have to. So as you can see, I ran this 2
This is
times.
the
So
last
now I
link
have
that I wanted to
10
get.
plus
He
10,
said
so
he had
the tables get
a space that
concatenated.
he could say
And let's do
share.
something cool. Let's sample from the other model now. Oh yeah, I'm bad with full screen here. I should put that guy in a full screen and this guy in another full screen. There we go. So yeah, I already trained the other model. So if we go here and nanoGPT, let me go back here. This is the first example. The second example he proposes is not training from scratch. So it's taking a pre-trained GPT-2 model on English, actually the OpenAI pre-trained model on web text, and then fine-tuning on Shakespeare. So that's a way easier task and a better approach. Like probably if you're going to use this model for your own data, you will not start from scratch. You will grab a pre-trained model.
Okay.
And then like
I'm glad he
fine-tune.
did. I'm glad he explained that part.
We use the same training
because that's
script,
what they were
but
talking
we
about
pass a
in
different
the
config. And
state of GPT.
basically this config has, yeah, as you can see, a lot of like options here. But this is if you want to run on a MacBook. Like I have a big GPU, so I don't need any of those. So yeah, I'm gonna run it once so you can see what I'm doing here. So we go back to our training script and do that by hand. By. So we pass the config. So in our case, it's config / Shakespeare. I'm missing here. It's not called Shakespeare. No, it's called fine tune. So we want to inject this config, fine tune Shakespeare. So yeah, here, as we are grabbing a fine tune model, we can grab the biggest one. So let's grab the 1.6 billion parameter GPT-2 XL. And that's why you will need a big GPU. So fine tune here, Shakespeare.py. And also you can actually use weights and biases here. So 1db log equals true. And let's try to make that run. This is actually faster than training from
Should be
scratch.
way faster.
Because
Should
we
be
only
way,
need to
way faster.
train a little bit the model with a really small learning rate. And we don't want to like destroy the capabilities of the pre-trained model. We just want to inject this, like align the model with Shakespeare. And we're going to do that. So yeah, this takes longer to load. It's loading a 20 gigabyte checkpoint file. So it's loading a pre-trained model that I think it downloads that. I can show you where it happens. Basically, it's on the model file. Here you have something called from pre-trained, generate estimate MFU, like configure optimizers here from pre-train, and it's basically like if you want Excel, it's creating the 1.6 billion parameter model, like 48 layers, 25 attention heads, big
Didn't they say in
dimension,
the state of
embedding
GPT
dimension,
we could
and then
use
it's like
GPT-4 as a
downloading
starting
that
point? I might be making that up, but I think
from
that's what they were saying.
Hugging
So
Face basically.
I'm gonna look back into that because I'll
So
probably
Hugging
work on
Face
this
put all
tomorrow,
these like
and I
API
would
that
like
enables us to
to
actually download models
maybe
pretty easily.
expand it out a
So
little
yeah, it
bit.
compiled the model, it fuses some stuff, make everything faster, 1.6 billion parameters, and it started our weights and biases run.
Hmm.
So
I'm so ready for this. Oh my
yeah,
God. Okay. Okay.
let's
Okay.
see how
Okay.
long
Okay.
it
Okay.
takes.
Okay.
If I don't remember, I think it takes like 1 minute. It says somewhere. No. I know it takes 3 minutes also. It's like equivalent to the other one. But the results, of course, are quite better. Like we are not starting from anything. So it's training there. This is like the first step, like just getting the initial loss values. And I really like to see here NVIDIA SMI. This is the big model I will use. Like I think everything is tuned for this GPU, so you will get like maximum memory usage here. But actually, you can check that here. Like if we go and we open that guy, we don't need to do that actually. We can go to the workspace. This is the workspace of the project, nanoGPT, and we see that the new run is coming. Like fine tune Shakespeare here, and still not much data. It's still only one step here, but yeah, the data will flow once the model start training here.
Hello, Thomas. There was one question by Sebastian. How did you use GPT-2? And I believe he was from Chile, if I remember correctly. So,
Cool.
fellow compatriot.
Okay, here, how do you use GPT-2? Basically, you have multiple ways of using GPT-2 now. Like you have GPT-2 built in transformers, probably the easiest way to get a GPT-2 up and running. This is like a bare bones implementation of GPT-2. If you go to the mol.py file, when he loads the weights, he basically has to like do some tricks, not tricks, but renaming some layers so he can override everything from the checkpoint that he's getting from the, so make the keys match. Like a model weights is basically a dictionary. You have like layers with names and tensors, and you have to match them. So when you download something and then you try to load that into, you download a checkpoint and you try to load that into a model that's created from scratch on PyTorch, you will need to make that match, like the keys with the values. So
So
he does some of that.
he's doing that
Yeah,
more from
probably you want
scratch
to do
in
that.
here,
It's
but
going to be easier. Like
Fast AI
GPT-2
does
from
that
pre-train, and
automatically when we
you're good
use
to go.
pre-trained
But this
models.
is like an educational
So they
reboot.
have that
So
extra
he
layer
actually does it by
that
hand. Here, like
tunes the
goes and checks
data
the
to
keys,
your
rename them,
this
and
tunes the
yeah,
pre-trained model to
transpose some
your new
stuff. You
data
know, like
set
because
before
naming
it
is not
starts
always
the
the same.
um,
And now this thing is training.
training.
So how many epochs are we going to train on? We can check here, fine tune. It's going to train for
I want to let him finish, but I'm going to
20
wrap up soon.
iterations. So there's no concept of epoch here. It's like iterations wise.
Sebastian says thank you. And then we had another one by Ron asking, what would be different for fine tuning on different tasks like Q&A or summarization or chats, etc.?
Mm-hmm.
Yeah,
It's the
okay.
actual data that you
GPT
train it on,
GIST is
right?
pre-training. So this is like a super kind of dumb idea, but that works super well. Like you're just predicting next token and pre-training on insanely big corpus of text, and you get a model that is capable of basically only doing that, predicting the next token. And so when you have these like summarization models or even like the chat models, they have other steps afterwards. Like they
Mm-hmm.
pre-train
So
and then
that
like
they showed us the different
they
layers
create
in
a
the state of
curated data set
GPT.
of questions.
So we
That's
should be able to
all what
figure out
has been
whichever layers
happening in the recent
we need to
months
go through as far as
about
the
people
training.
releasing data sets or even using GPT-4 to create data sets to train Alpaca or other LLMs.
I want to use
So
GPT-4
yeah,
to
you need
create
another
data
layer
sets,
of training after
at
this
least to create a
pre-training.
data
So
set.
you must see this as like this is a pre-training task that is already pretty good. you can actually use these models straight away. You try GPT-2 to generate code or generate all this stuff, you will realize that it's actually pretty capable. Um, but to get this finer, more instruction-based and aligned models, you need reinforcement learning or other secret sauce that
And
probably
that's
we're not
towards the
aware of.
end of the training process.
Another one from
Our
Tharva, one
LHF.
of our friends, ambassadors.
See,
What do you
now a lot of the
prefer,
stuff we were
epoch-based or
listening to the other day,
iteration-based
it has,
training?
I can have context to it.
I think for
So it makes sense to me.
this big corpus, it makes more sense iteration-based. And there was a recent paper, I saw that yesterday maybe, about this, about how many times you should actually show the models the data. And there's like, there's trades off. Like if you start like doing epoch, and when epoch is like, I show you the model once, the full data set. 2 epochs, twice. So it depends. Like if you have really small data set, maybe you can show that a lot of times. If you had a lot of data, maybe, I don't know, like I'm not an expert on that, but there's a lot of literature research into that topic. How many times you should showcase them all the same data. At what time you get diminishing returns, and maybe it's better getting more data instead of like showing them all the same data again. Um, you don't want them all to overfit, but what is overfitting exactly here? It's just the validation loss going up. I don't know. Like it's a complex research topic.
Thanks, Thomas. There's one more from Sharia. Generally, LLMs can take only n number of tokens. So how do large models like ChatGPT maintain chat conversation? Like suppose I've surpassed a token limit while considering the previous chat information as input tokens, then how can I get outputs since the limit is surpassed already in taking the inputs?
Yeah, I realize a lot of people think that ChatGPT is different than this, but it's the same thing. Basically, the model spits out the next token. So even if you're asking questions and answers, everything gets stuffed and sent to the model, and the model will predict the next token. And it will predict until it predicts the end token. So that's the end of your answer. So at some point, the model has 4K tokens, and this thing starts to pile up. So you can you can think of this as that as long as you go down in the conversation, every single call to the model is more expensive because you are sending the full past of your conversation. And this becomes obvious when you use at some point doesn't fit, it throws that away.
Awesome. We have 4 more minutes. So if there's anything else you wanted to cover, back to you.
Yeah, so this thing finished training. I'm just going to sample from that model quickly, and we can sample from this model. So it's the model checkpoint is here, out Shakespeare, Shakespeare, and we can also call 1db log equals true. And this model is better. Like this model already knows how to speak English correctly. And after some fine tuning on Shakespeare, we should be able to see that on the workspace. But that's basically the gist of this like nanoGPT introduction. This is a well-documented repo and super simple. So I encourage you to try it. Maybe rent a GPU for a couple of hours and try this just to give you an idea. Like I spent $35 on this and have been running for 35 hours basically. So it's 1 hour, $1 per hour. Plenty of time to try stuff, train. I actually tried to train the big model here. I think this one is the biggest one. And I trained like, I don't know, 30,000 steps. Still missing 600,000 the total. So yeah, pretty early. So encourage you to try this, play with it, use weights and biases. So as you can see, I can keep track of everything, single call I did to this nanoGPT repo. The tables keep piling up. So this is the latest table I constructed. It's not yet there because probably it hasn't finished. Yeah, it's still computing samples. So yeah, this looks like good English actually. So let's take a look. So yeah, I have 3 final slides here I want to present to you. So
All right. Well, I don't know where the audio is right now. Hopefully it's okay, but I lost the camera already anyway. So I'm going to pick this up tomorrow, but I appreciate everybody for jumping in. And yeah, we'll do training tomorrow for sure. So have a good night, everybody.